Please welcome Pere Monclus and Peter DeSantis.
Hey guys, my what?
Your magic.
Oh, I'm not going to use slides.
Thanks everybody for staying until this last talk. We have a guest speaker, Peter DeSantis, and I'm going to, before I introduce him, explain how I met him. I mean, it was 2-3 years ago, and I have a good friend that says, oh, you have to come to meet Peter, you have to meet this guy. I'm like, sure. So he takes me to a bar, and I meet Peter. And we sit with a beer in front. First question is like, oh, you work in SDN, you have thoughts and ideas about this. What's the difference between BGP and DHTs for managing a control plane and distributed control plane? And we get into a deep discussion about BGP, DHT, and things like that. And I'm like, who's this guy? Okay, the next question is like, oh, then what do you think about networking with strict consistency and eventual consistency and how the systems happen to be managed? And we get into that discussion. Then he starts, what about the Silicon Valley culture between the San Francisco and the South Bay? We start discussing that. We finish the evening, I go home, I go with my friend, I'm like, who's this guy? I mean, we were discussing like nitty-gritty details about technology and algorithms, and he's like, oh, he's managing the whole EC2, he's managing the whole AWS, I mean, he owns the infrastructure. I was like, wow, to be at that level, basically managing a business that is growing at a fast pace and have the time and the understanding to get into the low-level details of technology, that was awesome. So, Peter, nice to have you here, and maybe we start saying, what do you think about networking, what's going on in the industry, what's going on in cloud, and what are your views for the networking and the future of networking?
Awesome. Well, thanks for the kind introduction. I think what he's really saying there is I'm a manager at the end of the day, but I like to talk technology. So keep that in mind if we do Q&A. There is a line below which I haven't gone in a while. But it's a pleasure to be here. A really cool conference, and got to sit through a few of the sessions, and great content. So it's really fun to be here. When it comes to the networking, my perspective is this is a very exciting time for the industry. Over the last few years, the cloud has transformed the way users and practitioners are interacting with the network in some very cool and exciting ways. As a result of that change, I think that some very long-term, well-ingrained perceptions about the network are changing. And what I mean by that is, for decades, the network sort of earned a reputation as an unreliable entity. And the network likes to surprise us. It fails in sometimes unique and novel ways, and sometimes in frustratingly common ways. But it really has kind of accreted this reputation over many decades as being the source of many of the problems. And I think that's starting to change. I think that as the cloud is starting to gain traction, the network is starting to become something that people look at as a reliable part of the equation. And so I think the future of networking is, it's not the network, as opposed to it is the network. And so that to me is the exciting future, and that opens up a whole bunch of interesting avenues of innovation. It means that if you can rely on that lowest level, a lot more innovation is going to happen above. And so let me give you guys a little context. My background is as a software developer. So I started on the software side of the house, and I've been in Amazon a very long time. For the first 8 years or so, well before we had AWS, I was writing services that were for the consumer side of the Amazon business, and eventually went on to run our internal distributed systems and platform teams. And at that time, which was kind of late 90s, early 2000s, when things would break, we'd do much as we do today. We'd start a conference call, and everybody would get on a call, and within minutes of that call starting, somebody would hypothesize, normally without great data, that the problem that we were seeing was caused by the network. And so, in that first few minutes, usually 2 or 3 bits of data would be thrown about, none of which were conclusive, and everybody would be scrambling and running trace routes and pings, and none of which really helped us find the problem. And this would go on for several minutes, and then usually, more times than not, somebody would pipe up and say, I found a database with a slow query. So normally not, but lots of times it was a network problem. And a lot of times it was the same network problem we'd seen the week before or the week before or the week before. Every once in a while it was a new novel failure mode, which caused some strange interactions in our software. And so this is a big part of how I grew up at Amazon. And so kind of fast forward a little bit, I get asked to lead this team to build a new computing service, which we now call EC2, and that was very exciting. I was very excited about this idea because it immediately was apparent to me that the service was going to solve a lot of the problems that our internal customers were having with scaling and capacity management, and but it was also terrifying because of my experience with building services and debugging services. I knew that it was going to be the network. If there were problems, it was always going to be the network. Like, people were going to just lose confidence in this idea of EC2 because they were going to blame the network. And so really early on, the team and myself got some pretty strong convictions that we had to really double down on trying to figure out how we could run networking as a service. And fast forward, we're 11 years into that. Our performance has not been perfect, but we have been really, really happy with our ability to deliver extremely high performance to our customers. And we think that's a big part of the reason why the service has grown the way it has, AWS as a whole. And we also think it's a critical part of keeping this thing going. And so we've invested really heavily in, and we will continue to invest heavily. We're really, this is not a thing that's done, but for us, being able to get to a point where really the network is boring, right? There's no excitement. Nobody suspects it's the network. It just works is absolutely critical to this idea of cloud computing, and we think the future. But the other part of this that's exciting and very relevant to what you guys have been talking about here is, it really by getting this networking layer robust and solid, it's really accelerated some of the other trends we're seeing with innovation further up the stack. So rather than having one-size-fits-all networking that's part of some monolithic network, we've really opened the door to a whole bunch of innovation in different places, and I see that trend accelerating. I think that as the network becomes more of a service, it's also going to open up the ability for people to innovate, really push a lot of the problems that were traditionally known as networking problems up into the application space, and really get some of the same velocity that we've seen on some of the other things over the last 10, 20 years.
So what I'm hearing is that essentially there's no cloud without network, and that network should not fail. But seems that recently there was some failure in a public cloud provider about some load balancing issue. How do you make that Amazon doesn't have this type of outages? What kind of secret sauce do you have in Amazon network that we should know about?
Well, there's no secret sauce, and there is no, we always talk about our goals as providing a network which is indistinguishable from perfect. But we know there's no such thing as perfect in the world we live in, and so it's a continual investment from our side. But let me take a step back. One of the, I think, things that we've done right is that we've when we defined the network as a service, we exposed certain abstractions to our customers. And early days when we were thinking about what is EC2 going to look like, it was very tempting to want to ship a single global network and just really mask all the complexities and really just make everything look like one big happy network. But as probably everybody in this room knows, having a perfectly available, perfectly consistent global network is not a possible place to be. And so there's always going to be trade-offs that have to be made. And so we instead have really found religion around partitioning. And you have to find partitions that work for your customers. We've chosen, very early days, we exposed our service with this concept of availability zones. So the AWS infrastructure is made up of 16 regions across the world, but each of those regions has multiple availability zones. And each of those availability zones is a separate network, which is loosely and carefully connected to other networks. And so by doing that, we've allowed customers to make trade-offs in terms of consistency and availability that makes sense for their application. And so again, we're going to endeavor that each and every one of those availability zones has performance that's indistinguishable from perfect. But we're also going to be realistic about the fact that that's not possible over a long enough period of time and enough availability zones. There will be networking issues, and while we'll endeavor to make that zero, we will also accept the reality that there might be one and give our customers the ability, our developers and our customers, the ability to innovate and make their own decisions about consistency, availability, and performance by aggregating those pieces.
Nice. Another area that I wanted to explore is we've seen over the years that Amazon has been growing in terms of network capabilities. You started with VPC, security groups, elastic IPs, but then at the same time you had investments in hardware, smart NICs, and so on. So it would be good to understand, what do you see the future areas of investment from functionality, hardware, offering? How do you see Amazon evolving in the networking space?
Yeah. Well, I mean, we're going to make lots of investments, but probably the core of our investment remains focused on this concept that I was leading off with, which is how do we make sure that we can provide a network which just gets out of the way? And so I'll talk about maybe three areas of investment that probably won't be a surprise to anybody in this room. The first thing that, and we really started this very early on with AWS and EC2, is capacity solves a lot of problems. Right? The more capacity you can have in your network, the better you can deal with failure, the better you can deal with unexpected. And so what does that mean? Well, that really pushed us on this trend. Early days, that meant adding a lot of traditional networking gear to our data centers. And it was a wise choice, but it was expensive. And so it really got us going heavily down this path of how do we provide the most capacity in our network at the lowest possible cost. And so that caused us to abandon some of the traditional black box networking gear and look to our own routers, our own switch designs, and then build some of that logic that was provided by switches in our own software. It also allowed us to take ownership end to end, which had some other nice benefits. So we're going to continue on that trend. And I'm very excited. I would say, I think that really over the last 10 or 15 years, the hardware ecosystem is sort of withered quite a bit. But my personal perspective is that there is a lot of renewed energy and investment in the networking silicon space. And I think that's a great thing in general, and I think it's going to lead to faster innovation and faster increases in capacity, which will help all networks. Second thing that that is not going to surprise any in the room that we invested extraordinarily heavily in and continue to invest heavily in is monitoring. And so much of the reputation of the network has been a result of these, I like to call them gray failures or partial failures in the network, where our traditional passive monitoring techniques have failed to detect the problem, sometimes certainly before the customer or the user noticed, but sometimes hours or days later. And these things are insidious. They're small packet drop rates, they're small packet corruption rates, they're latency changes. And so these are the problems that have been plaguing network operators and software developers and really the whole industry for years. And so one of the benefits of running a truly at-scale network is you can invest very heavily in active monitoring. So if you have excess capacity, you can use real flows, real user flows, as well as synthetic flows throughout the network to constantly interrogate it and triangulate and auto-remediate any problem, sometimes even before the problem happens. So you can see leading indicators of problems. This is one of the things that really has benefited us at scale. So the more scale we have, the more experiments that are being run, the more we can correlate user experience to things that we can see in the network, and then the better we can learn, if you will, and apply some of the data techniques to predict the failure and remediate it before it's even a customer impacting possibility. And then the third big area, which won't surprise anybody in the room, especially maybe after the last talk, is we've invested heavily in our packet processing capabilities. And so when we started AWS and EC2, our packet processing capabilities are really the underpinning of how we provide a multi-tenant virtualized network to our customers. And so to do that, we have to touch, manipulate, validate every packet on the network. We originally did that in software, but well over 6 years ago, we started moving, despite I would say we did that in software originally, and we had some really good software people spending a lot of time optimizing it. But at the end of the day, software doing that in software did not yield the sort of consistency. And so again, back to my gray failure point, one of the hardest things to deal with as a software developer is consistency. If availability, jitter, I like to call it, but really variability in the network is probably one of the hardest things to program around. It's much easier to deal with hard failures. And so when we have big variability in packet delivery times or in packet loss rates, it's very hard to get your application to run right, and you're often going to suspect the network's the problem. And so that's no way to run a network as a service. So this investment in that packet processing capability, moving it from software, moving it to hardware, allowed us to do several things. The first thing it did is allowed us to create a very compelling security boundary for our service. So by moving to an offload packet processor, we can really reason about security in a way that you can't if you're running in software on the same host as the customer is running their workload. But secondarily, and very important when it comes in the context of running a network as a service, we're able to achieve extraordinarily consistent performance times. And so I said we started that effort probably 5 years ago. We've actually gone as far as to develop our own silicon, and we're on our I think third generation of network processing technology that we've developed in-house in conjunction with some folks that joined us a few years back from a startup. And so super exciting space for us, but really, we're not done there. We're going to continue to drive down latencies, but also while driving down latencies, continue to focus on consistent performance. Because again, if you're either developing additional network extensions or applications in a cloud environment, consistency is fundamental to being able to trust the network.
Yes. Switching gears a little bit, it's interesting to see that you started your career as an application development, services, and so on. Infrastructure has become kind of the dominant force that Amazon cultivated with the cloud adoption very fast. But now the wall is shifting. It's going up the stack. A lot of things are happening in Kubernetes, service meshes, Istios, Envoys. Would be interesting to see your perspective as an ex-developer now owning the infrastructure, seeing how those trends affect the industry, how they affect cloud, how they affect networking, and how do you see Amazon going towards those layers of networking as they evolve?
Well, and this is where this whole vision gets exciting for me. So when we can take the most fundamental aspects of a network and treat it like a service, it means that we can now innovate much more quickly in things that have traditionally been associated with the network. And so when you think about things like load balancing, failover, routing, discovery, these are things that are very application specific. And so my view of the future is you're going to continue to see innovation from all directions in this space. You're going to see I think you're going to see service providers like Amazon continuing to innovate and provide new abstractions. But I also think you're going to see ecosystems of developers and startups and others developing extraordinarily compelling networking abstractions as well. And they're going to be very tightly coupled to what you're trying to achieve with the application. For example, the services that emerge around high-performance computing and scientific computing are going to be very different than the abstractions that emerge around container architectures, because the requirements are very different. And so, but what's exciting is really finding a better place to cut the line between the network stack and the application stack, and pushing those problems, many of which are at their core distributed systems problems, into a layer that can move quickly. But I also think you're going to see some, one of the things I'm very excited about is in AWS is, we've, in the last year, about 7 months ago, released our first FPGA instance. And so we've got an EC2 instance, which can scale up and scale down just like a normal traditional instance, but can run programmable logic for an FPGA chip. And so what does this mean? Well, this means that developers and startups can start to develop interesting network appliances that run for our customers in AWS that actually take advantage of FPGAs. And so now there's no enterprise environment today where you can dynamically scale up and scale down the number of FPGAs processing your traffic flows based on, so that combination of pushing innovation out to the edges, but also running the fabric as a service is tremendously enabling. So my view is we're going to see more, not less.
Nice. And in this world that basically we are evolving, as you say, towards the application, seeing more of that, how do you see the bridge between, let's say, the public cloud and the private cloud? How do we interface the two of them as people demand all the capacity and all the capabilities that you have in the public cloud, but at the same time they have existing environments and environments that are growing in the private?
Yeah. Well, I think this, I like to say that people often ask, are folks running, what do we have in the way of hybrid functionality for AWS? And, it really, if you think about it, every AWS customer who's not born in the cloud, who didn't start in the cloud, that's taking use of, which is all of our large enterprise customers, are running hybrid in some way, shape, or form. And so super important area of focus for us. I think that there's going to be an appeal to folks moving more and more workloads to the public cloud, and one of the reasons for that, amongst many, is this, the fact that they no longer have to worry about the network. But the delivery model today, and you saw this in several of the talks here, it's changing. You're not buying monolithic boxes anymore that's providing this. You're either buying software or you're buying much more scalable, much more easy to operate networks. And so I think you're going to see hybrid architectures which allow customers to have very similar capabilities on both sides in their data centers and in the public cloud. I think an excellent example of that is, which hopefully everyone in the room's heard about, is the VMware and AWS partnership. If I think 5 years ago, was that possible? It wasn't possible for either of us, right? It's really the investments that AWS has made in turning our network into a service, and the investments that VMware has made in terms of their software-defined networking capabilities with NSX that's made that possible. And so now, bringing those two things together, customers don't have to choose between the public cloud or the management capabilities of VMware. They have the ability to do those things both, which is, I think, super exciting and probably a pattern we'll see more of.
Yes, we are very excited to see this flourishing and seeing how the infrastructure blends across both sides. With this, it would be good to start opening the questions to the floor. So if you have questions, please come in and we can address them.
Hi. It's been interesting. I've been at FutureNet and sort of seeing some of the advances that the larger cloud people are driving. James Hamilton at Amazon has written about the mainframe model of networking and networks being in the way. But yesterday we had David Sheridan advocating for proprietary black box, model of networking. And so how long until enterprises follow what you guys do and start pulling apart networks?
That's a hard question. There's certain parts of those inputs that I talked about that are really hard to do, even for the largest enterprise. I mean, there's just investments. I think that you'll continue to see folks trying to make some of those things easier to do at smaller scale. But if I think about the investments, Amazon was a very large enterprise with a very large network when we launched AWS. And over the last 11 years, we have learned so much in terms of there's just so much accreted IP and all of the monitoring and the switching, and it's really hard, and it's not easy to package it up. We've talked about wanting to package it up, and a lot of that is not easily packaged. And so I think that there's a big trade-off when you're thinking about running your own network, about do you want manageability and simplicity, or do you want to go and really bite off these big efforts? And I don't know how you reconcile that unless you're going to do it at very large scale.
And maybe following up some of the discussions we had, there has to be a combination of the processes and philosophy that you have inside your company. If you think Amazon decided to change the methodology because basically network was fundamental to make the service running. In the enterprise, as we were discussing today, you have processes that maybe started 10 years ago that now are being followed, and as the technology evolves and it moves forward, maybe those processes need to change to bring some of this mindset in the enterprise in a way that then the bridge between the enterprise and the cloud becomes more seamless. And maybe as we wait for the question, I was thinking on that question too. As Amazon starts providing basically more telemetry, as you were saying, more capabilities, more visibility on what the application is doing, we had a set of talks yesterday about intent-based networking, intent-based application. Now it's kind of the fashionable word that we can solve everything by expressing what we would like to. do, and then the infrastructure somehow is going to achieve it. Do you envision like evolving languages from CloudFormation to things like that as this new movement of intent percolates across all the layers of the stack, tying it to your telemetry and the services that you were mentioning that you have in the pipeline, and how to kind of use those to blend environments?
I think there's some real interesting ideas in intent-based networking, and I think they're, they make a lot of sense, and I think we're going to see a lot of progress there. There's a bit of it though, from a cloud perspective, again, going back to kind of my initial fear when we launched EC2, I don't know that we get to say you didn't tell us what you wanted to do and therefore it didn't work. And so our challenge is to look at, really expect the unexpected and figure out how to make it work. And so at some level, I think that there is some optimization that will come from intent-based networking, but my view is, as a cloud provider, is how do I not make it the customer's responsibility to tell me what they want to do, but rather just let them do it and then make sure that they can do it. And I think the latter, from a customer perspective, is a more compelling place to be. It may not be possible in all cases, in which case some of the ideas of intent-based networking might actually turn out to be huge levers. I'm not yet ready to give up on the former, though.
So we've been hearing trends around IoT and edge becoming more prominent again, and both Amazon and when I see Microsoft, there's an emphasis on edge networks. Amazon had interesting experience around having more POPs that are spread all over the world, other than your availability zones. How much of what you learned in creating these POPs and creating these content delivery areas and things like that could be translated into hybrid cloud networking space? I mean, are there any reference designs, or are you planning any open source projects around that?
Yeah, great question. I certainly spent a lot of time talking about data, kind of the data center fabric. We spend equal time thinking about the end user networking and the edge. Edge confuses me because people call different things edges, but the edge network, if you will. So for us, there's really there's nothing. We use many of the same techniques to manage traffic flows from our customers' computing instances to the edge, to the end user. You really have to make sure you have enough capacity. There's a lot of people when they're talking to you about their edge capabilities will focus on how much fiber do I have, how much backbone capacity do I have. It turns out that by and large, for most use cases, you don't really care about whether the packet is on dark fiber, lit waves. What you care about is how reliably and at what latency is that packet getting to my end user. And so it's producing enough capacity and enough redundancy in the network. It's figuring out how to let your customer monitor their workloads, and then ideally you're routing that traffic around before they even notice. And so to me, the fact that customers today that we have to think about edge nodes is a level of complexity. I don't think that's part of the network that I think should be below the line. But so I don't think that it's a world where everybody needs to. I think that's a bad world to live in, where every customer has to think about putting outposts at every part of the internet. I think the internet and the internet service providers and the fabric need to figure out how to make that easier for customers. So, but it's a super important part of the infrastructure.
So you mentioned in your previous life, I don't know, 17, 18 years ago, you were an app developer and there were these calls, and eventually someone with little data would come back and say, oh, this problem must be the network, right? If you fast forward to today, a developer running on AWS experiences some performance problem, something goes slowly, and eventually in that same call, someone might, with little data, come and say, oh, it must be Amazon, right? So how can you provide information to the tenants and share information with the tenants? There's certainly a barrier caused by the abstraction. You don't see some things that the tenant knows, and the tenant doesn't see a lot of things that you know. So how do you cross that barrier to make this understanding who's at fault easier?
Yeah, good question. And that really, So I'll tell you what we have done, and I also think that your question's an important one because it's something we have to continue to innovate on. Because in order to deliver the promise of cloud, you really do want to be able to create the network as a service. And so, if I have to start talking to customers about routers and routes and paths and packet drop rates, the whole thing falls. But you're absolutely right. We need to give telemetry, the right telemetry to our customers so that they don't have to ask, is it the network? And we've accreted a number of more detailed metrics over the years to our customers with our services and our instances. And I think that's a trend we have to continue. Now, there's a competing tension that we have, which is we don't want to have, if we give 1,000 metrics, it's not so. In my ideal world, I would give you green, yellow, red, and mean it. Green being you shouldn't expect it's the network. Yellow meaning it could be the network, and red meaning there is a problem. And I think we do pretty well with green and red today, and yellow is the kind of mushy middle that we have to figure out a little better. One thing I think that that's a little different in a cloud environment is certainly if there's sometimes the problems that I think that we need to work on figuring out how to communicate better with customers today are very localized problems on a particular EC2 instance or in a particular, certainly any larger problem. One of the benefits of the cloud is that there's other people in the same boat, and so we're very quickly communicating, and you're seeing signs. Whereas if I rewind the tape to when I was running this on an internal network, there was some signal, but it wasn't sure. To my point, it was never quite clear if it was because everybody was depending on a common network or a common database, right? And so unfortunately, it was just a lot of noise. And so that is one benefit. I think we've done a lot with metrics, but I think telemetry is a place that you're going to see continued innovation because it's not a full SLA yet.
Thanks. Apologize if it's a redundant question because I heard a little bit of Pere talking about this, but your focus on reliability in the network. The number one fallacy of distributed systems is that the network is reliable. I love the modern software design and architecture of microservices. I think there's a lot of value in that, but you're putting the network core to the application, and so my question is, what do you think is critical from a platform perspective to make those application developers successful so that they're not lost in the fallacies of distributed systems?
Yeah. I think what you'll find, the fallacy that I think is, as a cloud provider, we did not want to provide the illusion that there was just this single perfectly available global network. Because once you do that, there's no rolling back. And so we do provide a number of high-level features that allow our customers to reason about things. That the ones that fit within the availability envelope of what we're providing can use things like elastic IPs and fail them across availability zones. And so that's one way to access the network as a service. But it's also important to provide the more primitive bits, and that's where concepts like availability zones are so key. And so by providing availability zones and strong guarantees around the network and state isolation of those networks, the application framework providers or the application developers, if they are distributed systems experts, can actually choose their own availability and consistency trade-offs. And so my view very much is this has to be an and. We have to provide the primitives, and we can also provide for customers on a one-by-one basis to select simpler paradigms if that's what's appropriate for their application. But I also think you'll find service providers and the ecosystem of open source software and one thing, open source software is very compatible with cloud computing, and they're kind of better together, if you will. And so I think you'll find that a lot of times there'll be these as we're seeing with some of the proxies that are emerging around containers, you're going to find communities banding together to solve some of those problems. And the fact that they all have access to the same network and the network service and it performs the same for each of them means that this open source software is going to run better, right? As opposed to having to marry the efforts of the open source community with the efforts of your internal networking team, which can sometimes cause you to have to take on actually more work than if you're able to kind of talk about the network in the same way or in a limited number of ways.
And maybe following up on the question of Chris on the meaning or the role of networking as the application becomes more tied to it. Now we are seeing this fundamental shift to Lambda functions. And now you say, well, Lambda functions may or may not still run within a context of execution of a container, but let's assume that they are not for a second. Is networking turning into, let's say, identity management and policy and metadata carried between execution units that are stateless? I mean, how do you see this, the time that so far we are so used to think, oh, networking is about IP address and management and moving packets and so on. But then you have this thing called Lambda functions, and they question a little bit the way we think about networking. Even today, maybe they are built upon similar principles, but will these principles hold? Do we have to revisit that?
Two things. So I'm personally very bullish around serverless compute as a paradigm for, I think, a large, if we look ahead 5-10 years, I think we'll find a large number of applications that have been built with serverless paradigms, because it's, for many applications, I think it's a preferable way to, thinking about things like servers and IP addresses is cruft. And so I think you're going to see that gravitation. You're absolutely right. Some of those things will start to shed abstractions like IP addresses and use higher level abstractions of identity and permissions. But I think that the most powerful environments will allow you to combine those two abstractions. And so having the ability to see these higher level abstractions, but also open the hood if you need to and understand how they interact with lower level abstractions, and then being able to combine them in useful ways. So something that you so an application that has to run in a server full, that's a new term, I think, server full world, it can interact with in its native tongue with a serverless, just like any other hybrid environment. I think that's going to be super important for both the traditional as well as the new way of writing applications. So I think we're going to see more of that, but I think that the most successful serverless paradigms are going to understand how to interact with the servers as well, at least for a while.
Please don't be shy. I mean, come and ask questions. Meanwhile, I'm going to explore this server full.
Server full.
I mean, if you think, as we evolve into this paradigm, let's assume that server full, and we are going to have serverless functions in multiple clouds, in multiple providers. Mm-hmm. If you think like many years ago, we came from this world that there was no unified identity management model, and then we had all the IAM revolution and all the meaning of who controls the identity and the passport aspect of the internet and things like that. And somehow we've lived that revolution that identity was a fundamental aspect that we had to control when associating it to individuals that they wanted to communicate to each other. Mm-hmm. And now we are getting into more or less a similar world where instead of individuals are serverless functions. And serverless functions may exist in Amazon, may exist in other places. And now you have, for example, AIM in Amazon that you can define identities and roles and policies and so on, and then you can attach them to a VM, to a container, to a Lambda function, and then you can create these amazing, powerful security constructs that they cross any boundary of networking. You can say this S3 bucket associated to that Lambda function, but not to that VM and that container. So now, if you take it to the extreme, imagine that now you have serverless across everywhere. Do we need a way to federate identity across cloud providers in a way that we can enable this server full wall and from an application developer not to have to worry that they have to understand identity and policy and things like that in one environment versus the other?
I think you're poking on a trend that is real. I would have put this in a slight. One of the things. I think when we thought about cloud initially, one of the first things that didn't make a lot of sense in a cloud world was a firewall. And so we actually launched we did allow people to launch with this idea of an IP-based firewall, but we introduced this concept of a security group early days, which was it seemed like a imperative building block in a dynamic environment like AWS. And I think that those sorts of concepts of identity are going to continue to expand, and I think you're poking on So one of the things we're doing in the container world and probably in the server world as well, is we're trying to marry up some of the concepts that we have, bring the concepts that we've had natively on EC2 to containers. And so things like security groups and elastic network interfaces and load balancers, things that, so we want to get to a world pretty quickly, we're getting to a world pretty quickly where a customer can have Lambda functions and EC2 instances behind the same logical load balancer. And so I think then it's a logical extension of that to say, how will it talk across the internet. The other thing I'll say is, I think that another part of the future of networking is, and I think everybody's seeing this trend, is there's going to be fewer walled gardens over time, right? The idea of a hardened shell and relying on that hardened shell to provide some sort of security boundary or the illusion of security boundary is a fast fading illusion. I think that I think that soon people are going to give up on the idea that things are not actually all connected by this thing we call the internet, and are going to really not think about to me, it's an anathema to think about an internal service, and I've said this for years. There's no such thing as an internal service, right? So I don't want to understand a different set of monitoring or a different set of permissions or a different set of a service is a service. It needs to have the same. It needs to protect itself. It needs to be secure. It needs to operate. It needs to have an SLA. And so I think that you will see this. I don't think you're going to see these concepts of walled gardens persist. They're
makes sense.
Too limiting.
We've seen them coming and going in different stages of the internet or the communication history. So completely agree with you, and that's probably the next frontier to explore in the meaning of cloud computing.
All right.
With this, if there's no more questions, I would like to thank Peter for coming here and spending some time with us.
Thanks for having me.
And thank you, everybody, for spending a couple of days with us exploring these directions. As said, we appreciate a lot if you can send us a feedback on what you like about the conference, the talks, the ideas, and how we can make it better next year. And safe flights back from where you come from. And looking forward to seeing you next year. Thank you.